Alright, so here is the second part of 11.2 with the last three examples that we haven't done yet. For this one right here, just like in the previous, I'm going to leave the right hand side alone and we'll mess around with the left. So cotangent, we can change to cosine x over sine of x times cosine of x over 1 plus sine of x over 1. Now, as the tip says right here, we can combine fractions. First, I'm going to take this left-hand side, multiply them together to get cosine squared of x over sine of x plus sine of x over 1. We have two fractions here, but our denominators are not the same. So we can only combine our fractions if we can make the denominators the same. So I'm going to multiply the second fraction by both sine of x on the top and the bottom. This now will give us cosine squared of x on one side for the first fraction. And on the second, we end up now with sine squared of x over sine of x. Each fraction has the same denominator, so now we can combine the fractions into one. Cosine squared of x plus sine squared of x all over sine of x. The top portion here is one of our Pythagorean identities, cosine squared plus sine squared. That's just going to be 1, which gives us now 1 over sine of x. And 1 over sine of x is going to be the same as cosecant of x, which is what we had to start, which means that we have now verified our identity. Alright, so with our combining fractions, we are going to have to make our denominators the same. And to do that, we need to make sure we're multiplying the top and the bottom by the same amount. So with the last two examples here, they're going to be doing the same process, but there will be significantly more steps to it. For this one right here, I decided I'm going to leave the right-hand side alone, and I'm going to use the left-hand side to change everything. So the first thing, tangent here, is going to be the same as sine squared theta over cosine squared theta minus keep sine squared theta as is. Both sides, here I have a denominator of 1, here I have a denominator of cosine squared, so I need to make this fraction the same by multiplying the top and the bottom by cosine squared, which gives us sine squared theta over cosine squared theta minus sine squared theta times cosine squared theta over cosine squared of theta. With our denominators now being the same, we can combine this fraction into one. Sine squared of theta minus sine squared theta cosine squared theta all over cosine squared of theta. Combined our fractions. Now we're actually going to factor just the numerator because both terms have a sine squared in them. So when I factor the numerator, you get sine squared theta equals 1 minus cosine squared theta all over cosine squared of theta. Alright, move that up. In our fraction here, this is one of our Pythagorean identities, alright, which would allow us to change sine squared theta times sine squared theta over cosine squared of theta. All right. And sine squared over cosine squared, that is, again, one from our first section. We can change that or simplify that to be tangent squared of theta. We still have in the parentheses sine squared of theta. And this now will match our other side where we have tangent squared of theta and sine squared of theta. So now we are verified. Alright, so now that we have that one done, we got one last example to do here. To give myself some more room, I'm going to erase the previous example. Once this board catches up here, we're going to clear that off. buffering and moving slowly. So